Hello everybody. Today I'm going to discuss about the magnetotelluric method of electromagnetic. I'm going to give you guys a comprehensive overview regarding magnetotelluric method and briefly discuss about the introduction and working of the method with some models. So what is a magnetotelluric method? It is basically a passive technique of electromagnetics, uses the variations of electromagnetic field of Earth to determine the conductivity and the resistivity of the subsurface, and later on the computer-based modeling used to create a theoretical response. The MT is a simplified or abbreviated form, which means magnetotelluric. Magneto and telluric are the two terminologies together, which means magneto means magnetic and telluric means electric or related to current. Later on we will come to know that by using this method what actually we get to know about the Earth. So the MT is one of the few techniques capable of sensing through the Earth's crust to the upper mantle. So when we talk about the Earth crust to the upper mantle, then it means that with the help of this method or this technique, we can collect the subsurface data from tens of kilometers to the hundreds of kilometers up to the upper mantle of Earth crust, upper mantle of Earth subsurface. This is electrical conductivity range over the orders of magnitude. The range varies from 10 raised to the power of -16 to the 10 raised to the power 8. Different magnitudes are set to find out the conductivity and resistivities of different rocks, lithologies, and strata. For instance, if we talk about copper, so the electrical conductivity wavelength or frequency for the copper is 10 raised to the power 8, and silicon lies on the negative side, 10 raised to the power -4. When it comes to the Earth's crust, we all know that it comprises of silica minerals mostly. Up to 95% of Earth's crust consists of silica minerals, which is highly resistive, and the electrical current which is highly resistive to the electrical current. The magnetotelluric method has been used successfully to locate the under thrust sediments or tectonic frameworks, regions of metamorphism and partial melting, and fault zones as well. In case of mantle, the temperature is very high. The high temperature results in the very high conductivity. So the magnetotelluric method has been used successfully to identify the partial melts, variations in lithospheric temperature, and for asthenospheric. The interaction between the Earth magnetic field and the solar wind creates small variations in the Earth magnetic field. In fact, very small variations. These variations induce electric currents in the Earth because of the large conductivity contrast between the space and ionosphere. Electromagnetic waves are bent to vertical incidence. These vertical incident waves impinge on the surface of Earth. The graphical representation of magnetic pulsation in the lower frequencies, and on the other hand it is showing the relationship between the range of frequencies to the field strength. The range of frequencies used for probe lower crust, 10 raised to the power -4 to 10 raised to the power +4 versus field strength. This is a very good display of conductivity distribution and the way of how it is measured. Let's look at the governing equations of electromagnetism. Basically these are the wave equations or the modified form of Maxwell equations, and below is the further calculations for the of these Maxwell equations. I will not go in much detail of these calculations because it's gonna take half of my overall presentation in just these calculations. Just these are the governing equations. There gonna be no difference between the area of 1 kilometer if we consider space and vertical incidence plane wave. Z is equal to h by E by h is a wave impedance of free space. In the 1D Earth layer strata, these principal impedances are equal, but for the 2-dimensional Earth, these are aligned along and perpendicular to the structural strike and are unequal, and for the 3D they can be very complicated. The vertically propagating transmitted electromagnetic waves is dissipative because of ohmic losses of energy. The skin depth increases with decreasing frequency, increasing period. So lower frequency penetrate deeper. Lower frequency penetrate deeper into the earth than higher do, as shown in the figure below for the standard empty sounding curve. This is a pseudo section for the lateral 100 kilometers. For the multiple sites, we often plot a pseudo section. The TM mod means E waves or transverse magnetic waves, and TE mod means H waves or transverse electric waves. When it comes to the interpretation, 1D modeling or inversion is very fast, easy and readily available, but it is not reliable. Most of the times it is not reliable, and if we say that it is also justifiable if we can say that it is almost always wrong. And 2D modeling and inversion is slower, more difficult. Programs usually available may have 3D effects in the data. And for 3D modeling, used to verify 2D results. Programs available, but only simple models possible. Uh, Overall, the 2D standard inversion is 2D inversion is the standard tool for interpretation. MT can provide resistivity sections at many scales for the uppermost crusts to the entire crust. This is an example of high resolution MT profile in Kyrgyzstan to determine neotectonic structure. This is the MT profile across Sierra Nevada and Eastern California. The MT model and inversion are regional problems that in the Sierra Nevada are affected by the highly conductive Pacific Ocean and all of the structure in between. Mackey et al. In 1996 showed a 3D model of California that the transverse ranges resistivity affected electric field levels in Death Valleys. And this is again a section 2D model over the area of over 300 kilometers laterally against the depth of over 300 kilometers.